Welcome to another episode of Automotive Insiders. I'm your host, Jason Stein. Great to have you back with us again. Every week, we take a look at the conversation shaping the supplier industry, and today we're focusing on one of the most important transformations of all, building a sustainable battery future. The shift to electrification has set off a ripple effect that extends far beyond the vehicle itself. It's reshaping supply chains, redefining material sourcing, and challenging every stakeholder. From solid state breakthroughs and new chemistries that reduce reliance on scarce materials to recycling and reuse systems that close the loop on battery life, the path toward truly sustainable electrification is accelerating, but it's also demanding unprecedented collaboration across the value chain. To help us unpack what the future looks like and how the supplier community can lead the way, I'm joined by Matt Orlando, Director of OEM at Mitsubishi Chemical Group, a global leader driving innovation at the intersection of materials, science, and clean energy. It's Mitsubishi Chemical Group on Automotive Insiders. Matt, a pleasure to have you on the program. Thanks for being a guest here on Automotive Insiders.
Well, thanks for inviting me, Jason. I'm looking forward to this.
The overview on this is that we really want to talk about building a sustainable battery future, but I want to start with how are advances in battery technology reshaping sustainability in the automotive supply chain?
Well, I mean, you see a lot of things that are happening right now on a lot of different fronts on the regulatory part. But if you look at the technology itself, you see a lot of momentum right now around the solid state. Everybody keeps talking about that being a better battery, a safer battery. And so you see a lot of innovation going in that way. I hope too that once those things mature, because it's not really there yet, but it's getting very close. I hope that those batteries provide the longevity on the battery system, and that a lot of people will evolve in that way. So there's certainly a lot of opportunities that are going in there. I see sodium ion as an option too, a much more abundant chemical that's out there. So there's a lot of different technologies going.
And improvements that have been made, maybe you can just talk a little bit about some of those things. Improvements in energy density, longevity, that's really will lower the total environmental footprint per mile, right?
Well, yeah, that and you also look at some of the localization that's going on now too. I mean, part of the footprint, we like to look at the LCAs, life cycle analysis, and a lot of our plastics and other chemicals that we sell. And so, getting a lot of these things, shortening the supply chain, getting them as close as possible to the point of sale is also part of the environmental impact, right? So, these are all things that we need to do. And I see, many, many more companies being built up locally. You see sources of, especially rare earth minerals, are trying to be resourced here to the United States right now, and we're trying to get the processing technology going. And then there's also a lot of other technologies to make the batteries better. Thermal technologies, right? Heat is the death of a battery. I have family members who live in Florida, and their lead acid car batteries last 3 years. Here in Michigan, they last 7. So we got to figure out a way of managing those heat, and those types of innovation can also be very, very effective at adding to the sustainability of a battery pack.
What steps are suppliers taking to make the battery supply chain more sustainable and transparent?
Well, I mean, you look at there are a lot of different OEMs. I don't know if I should name one over the other because they all have a lot of great initiatives. But a lot of them now are mapping the entire chain. We used to do that for, you didn't want minors or kids working in facilities and things like that. So on certain metals like cobalt and things, we'd had those rules and regulations in place for a long time. But now what you see is, hey, they're going all the way back to the mines, right, in the supply chain. So if you're taking a critical element or an assembly, they want to see the entire supply chain going all the way back to the raw element. They want to make sure that everybody has ethical policies in place with those. They want to make sure that when they do mine, they mine them in a way that has the least amount of impact to the environment in that particular area where it's being mined. And you want to make sure that it's also always available. Security is also a big part of what's going on right now in the world, and making sure that you can have it available for your customers, but your plants.
And there's really increased collaboration that's going on between OEMs and tier one and tier two suppliers, right, to enforce some sustainability standards. Is that right?
Oh yeah, it's absolutely it's the entire chain, and it's just not the OEMs and the tier ones. We've got customers that are going back tier two, tier three, tier four. Again, it's the whole mapping of the supply chain. It's not just procurement anymore. It's not that first level of buying a part. You need to show to your customers, upstream and downstream, the entire chain that you have. And that's an important part, especially for the batteries. Matter of fact, I think batteries are probably leading from an application standpoint, the visibility and the traceability of it. And you even see some software programs that are starting to track all of that right now. And we talk about potentially in the future, on batteries, do you have some sort of Bitcoin type of encryption that shows where the battery was made, but also any of the servicing that goes on, what kind of repairs were made, those types of things, so that we can track how the battery is being utilized and where it's failing, where it's not, and how can we make batteries better in the future.
So let's talk now a little bit about sustainability intersecting with cost in battery production and supply. Give us an overview on that subject.
Well, um, we've seen lithium go through absolutely through the roof and then
Hmm.
crater. So it's been one of those supply and demand type of items. I think that as we see this transition from ICE vehicles towards more of the battery or EV or hybrid types of drive systems, as we start to see that, you're going to see a lot more stability. But I also still think that, cars being a 130-year-old invention, um, it's gonna still take a little bit more time to move forward. The rate of pace of change in the battery development right now is still incredible. And until some of those things settle down, I think you're gonna still see a lot of instability going on.
And that instability, I mean, there's an important part about sustainability as it relates to cost and battery production, but it's also market differentiation, right? So sustainability becoming a cost of entry, not a premium option anymore. Do I have that right?
Right. Yeah. Yeah. And again, you see a lot of people who like to use the LFP because it's low cost, right? It's low cost, it's durable. But at the same time, when I look at that from an initial cost standpoint, if we talk about sustainability, again, we've got to look at the entire value chain, right? So, we've talked with companies like Serba Solution, who's doing the recycling. You see, Cox Automotive has got a recycling. The big announcement yesterday was Redwood's Series E that was oversold because, again, there's a lot of people who are interested and excited to be part of this battery group, but they also realized that post consumer was a weak area and it needed to have some investment in it. But when you talk with these companies and you say, hey, there's these low cost batteries up front, like an LFP, they say, yeah, but there's no value in recycling it. And so you say, okay, well, what are we going to do? We're going to put like a bottle law, a deposit law on a battery to make it worthwhile to recycle. Whereas when you look at some of these other, nickel types of batteries, there's more in them so that at the end of the consumer life, there's more value in the metals. And so people want to recycle those more than they would an LFP battery. So I still I worry about talking about initial cost of a battery versus the total life cycle cost. And again, that gets back to, like I said, these life cycle analysis we do for carbon. I think we also need to look at the life cycle analysis on cost. And how do we do that? And how do we handle that post consumer cost? Because it's a cost, right? I mean, you got these companies when they're shredding the batteries today, they get basically they can take out some of the metal case, and a couple of other things. Everything else right in there, right now, they're not able to recycle really the anodes and the cathodes materials. And so a lot of that ends up just getting ground up into a black slurry and it's shipped offshore. Well, is that really the right thing to do? It's something we can do now, but we've got to find better way. We got to have more investment in the downstream, and we've got to have something worthwhile to recycle. And that also gets back to not just grinding everything up, but what can we reuse? I think that's something that we really need to figure out how to do in the batteries, and it's an opportunity that really hasn't been fully vetted out yet. I mean, batteries are changing from, one vehicle to the other, and all this innovation, and it's really great. But because of that, you can't go back and service the first level of battery anymore. So it becomes disposable, and that's bad. That's bad for the overall economy.
And I know finally there's a push toward a net zero battery supply chain by 2035 to maybe 2050. But also, Matt, more cross industry collaboration between automakers, miners, energy firms to secure clean, ethical supply, right?
It's got to be there. It's got to be there. And again, there's auto is a huge opportunity for companies who are doing batteries and battery technology because they're big and the volumes are there. But when you really look around at some of the adjacent industries, the drone industry, for delivering packages or medicine, or looking at when there's an environmental disaster and you're trying to look for survivors, the drone industry is going to be it's just an amazing industry. It's mostly based on batteries, on electric motors and batteries, and so we have to keep thinking about those things too, when we look at this whole environment and how we do the sustainability, and how can we collaborate, like you said, between these industries. Some of these drone industries, I think, are gonna they're gonna iterate faster than a car platform. Car platforms are notoriously long, 2 3 year lead times. In China, maybe it's only 18 months, but you see some of these other industries using batteries where they can innovate in 6 months, right? Their product cycle or their product life is 6 months. We've got to figure out how to learn from that, innovate faster, and then use that to help the big scale, the heavy capital intensive industries like the automotive industry.
November 19th at the MEMA annual conference in Novi, Michigan, there will be a sustainability discussion at 12:15. That's actually a breakout. Mitsubishi Chemical Group will be represented there. Matt, thanks for setting the field for us.
Hey, thanks a lot, Jason. I appreciate your time.
Thanks again to my guest, Matt Orlando, Director of OEM at Mitsubishi Chemical Group. Thanks for listening, and come back to this platform for more conversations with leaders across the industry. I'm your host, Jason Stein. We'll see you again next time.